Hello, everybody. All right, coming to you from my kitchen while my children are at gymnastics. All right, here we go. So the first thing we're going to talk about today with 1.3, we're only doing 1.3 today and the review for Chapter 1. So the first thing we're going to talk about today is the steps for designing a statistical study. The first step is to identify exactly what you want to study. As far as like what exact data do you need to study something, and how you're going to go about doing that. And that's step 2, is to develop a detailed plan to collect your data. Something I should probably remind you of right now is that you can pause this video anytime you like. You're not watching it at the same pace as anybody else. So you can pause anytime I'm going too fast for you. Step 3 is to follow that plan and collect your data. Step 4 is to describe the data. This is that descriptive statistics part. That's just the facts. Step 5 is to interpret the data. And make conclusions about a population. This is the inferential part. And step 6, which is the most important, is to identify any possible errors, because you might find out that your study is bogus. We will, in this class, be doing a couple different projects where you're going to design your own study and figure out exactly what you want to study and then do it. Okay, next up, 4 ways to collect data. The first way is called a simulation. This is used when it is too dangerous or expensive to do the real thing. A good example of this that you could write down if you want to, I'm not going to, but you can, is crash test dummies. It'd be pretty devastating to be like, let's just put a family of 4 in this minivan and crash it going 60 miles an hour against this wall and see how they do. So that's a simulation. A survey is just asking people. This can either be on paper or through a computer or a phone service. The problem with this is that people can be lying to you, or not realizing the truth is also another thing. An experiment. This is the one that has a treatment group and a control group, which we'll talk about in just a second. This is where you give some people a treatment and some people a placebo, and you do an experiment, like a straight scientific experiment, to get your data. An observational study is where you watch but don't interfere. This is good for figuring out people's true motivations, or especially anything in nature. If you really wanted to find out the mating habits of elephants, you'd probably just watch. You wouldn't ask them what their mating habits are like. You wouldn't create a fake elephant to do it. You wouldn't do an experiment. It would just be watching and writing down the data. A treatment group in an experiment So this is all experiment for the next 3. Actually, it's experiment kind of for all of these, so maybe I'll just write experiment next to all of these. A treatment group is the group that gets the treatment. I know that's a bad definition because it uses treatment and group in it. But like if you had a pill that you're using to figure out if you could, you know, stave off heart attacks or something like that, that they would be the group that actually gets the pill. A control group is the group that gets the placebo. It's important to have a control group when you're running an experiment because there's something called the placebo effect. A placebo is a fake pill or a sugar pill that makes people think they're getting a treatment when they not necessarily are. The reason why they do that is not just to be cruel, but to make sure that people aren't just reacting to the fact that they think that they have medicine. That would be like a psychological thing. Making sure that you don't just believe that you have medicine, so therefore you are all better. If there's no difference between the control group and the treatment group, then what that means is that it didn't work. A confounding variable is a surprise, I guess, variable that might mess up your study. Something you didn't plan for, but that turns out to have really made things a difference. Like, let's say that you're trying to see if you've got a supermarket and you want to see if, like, putting umbrellas at the end of an aisle, like in a display, will sell more umbrellas. But then that day it rains, and you do sell more umbrellas, but the confounding variable is the fact that it rained, because that probably caused it instead of you putting it at the end of the aisle. Blinding is when the people you are studying don't know who got the placebo. And this is necessary for anything with a placebo or a treatment group or a control group. If they know they got the placebo, then they're going to know not to react to it. So it's called a blind study. Backside. Oh, I'm going to run for 1 second. I got to get a graphing calculator. Okay, double blinding is when the experimenter also doesn't know who's getting the placebo. This is important because sometimes even when the experimenter doesn't mean to, they can be treating the